Welcome to this Appland presentation on how to bring security engineers and developers together with the help of visual code maps. Here's what we're going to cover. Demonstrating how visual code maps recorded from security pen tests improve collaboration between security and development teams, and how they can help organizations make their applications safer in a shorter amount of time. First, we'll introduce the concept of code maps, and then we'll jump into a demo. Let me first start with a statement. Our current workflow is broken. Security teams are experts at finding design-related security vulnerabilities, particularly those that elude typical code scanning tools. But finding those security flaws is only half the battle. Developers have to understand the flaw, find the root cause, fix it with a test, and ensure that the code stays fixed. This workflow, find, communicate, fix, and monitor, is broken, and it's leaving companies exposed to harmful attacks and developers left holding the bag. Here's where the problem lies. While security teams already produce a slew of artifacts in an effort to document the vulnerabilities they find, these artifacts aren't optimized for developers. It takes far too long for developers to wade through static pen test reports to understand flaws, find the root cause, and implement fixes that won't impact the larger code base later on. And that's time no company can afford to lose, both from a security and engineering resource standpoint. What security and development teams need is a more efficient and productive process for working together, and I'm going to show how they can do this with Appmap, an open source tool and data framework that records and maps application code as testers probe the application. So what is Appmap? Appmap is like Google Maps for code, and we call them code maps. The mapping feature shows you how functions, web services, data stores, security, I/O, and dependent services all work together. Appmap is different from any other software intelligence tool you've used because it collects information about how it works when the application runs. Appmap is primarily built for developers. They can use these interactive code maps to quickly orient themselves in unfamiliar code, understand how monolithic applications work, troubleshoot stubborn bugs, or communicate code design updates to their peers during code reviews. All that makes code maps a perfect tool for recording, exploring, and analyzing security vulnerabilities as well. Appmaps make it very easy to spot problematic code or database commands, and then navigate to the root cause, revealing literal blueprints of code flaws in applications. And because recording code maps is simple and automated, they're convenient for other teams to use as well, including the security team, making them a great technical resource to add to pen test reports. Now let me show you code maps of security vulnerabilities in action. I'm going to start this demo as if I'm a security engineer who is performing a pen test. My demo application is the well-known budget store that is riddled with security nightmares in its code. Here's a quick glance at the startup configuration. I'm adding an Appmap recording agent to the startup parameters of the app. The agent can be easily added to any dev or test environment. This is a Java example, but Python, Ruby, JavaScript, and PHP languages are supported in a very similar way. My application is now running and ready for my test. I will record a new code map of my attack with start-stop controls in this web browser extension. Similar recording controls are also available for scripts and in popular code editors. My first test is a classic example of reliance on cookies without proper validation of data access. When I open my basket as an unsigned user, the app creates a new basket for me. There's a new basket ID created in my session, and I can see that it's set to a number larger than 1. Let me set the basket ID to 1 and see what happens. Yep, I have just accessed someone else's basket. This concludes my first test. Let me now finish the recording and inspect what has just happened in the code of the application. The recorded Appmap is saved in Appmap Cloud and opens in a new tab. I can now inspect what code components and what code flows were executed during the test. I can see there were 2 calls to the basket JSP made during the test. This is the first call. I can see that a new basket record was inserted to the database, then fetched from the database, and then its contents were fetched. This is the second call. I can see that in this case, the code simply accessed the basket identified by the cookie without validating whether the basket belonged to me. I can now add a link to the Appmap to my report and share it with the developers. Now let me switch roles. As a developer, I can open the same Appmap in my code editor right next to the source code and investigate how my code was executed when my security engineer found this vulnerability. Note that I do not have to replicate the pen test steps or dive into a debugging session to do so. I can now poke around the code and match the recorded trace to the sources. I can clearly see and compare the code paths of a new shopper versus someone with an open session. The basket ownership validation step is clearly critically missing in the latter case. Now, this example is intentionally simple. The code is not pretty nor structured like a real application, but I can apply the same approach for real application code. I'll show such an example in a moment. Before I move to the second demo application, let me quickly show examples of Appmaps recorded for other vulnerabilities found in the budget store. This is a recording of SQL injection that shows how unsanitized inputs passed to the login JSP flow through the code all the way to the SQL commands. And here is an Appmap showing a cross-site request forgery, where an unsanitized comment sent to the admin resulted in taking over the admin's password. As you can see, rendering of the comments on the Contact Us page is immediately followed by a call to change a password, a clear indication that one of the comments triggered a password change request. My second demo application is the Rails Sample App 6th edition, a popular resource for mastering the Ruby on Rails framework. It's a modern Twitter-like web app that is properly designed, coded, and that also has great test coverage. One of our community members discovered a weakness in the app. If you know the direct URL, you can look up registered users and their details without being authenticated. Here's the recorded code map. This map shows that the code goes straight to fetching the details of the user requested by the HTTP call. There is no authorization challenge in place. My developers can now create an automated test that will replicate the problem, record with Appmap, and then compare the 2 Appmaps for similarity. Here's the new test that is expecting anonymous users to be redirected to the login screen. Let me run it now. As you can see, the test failed because the code does not redirect to the login page. And here's the Appmap recorded from the test. As you can see, it is very similar to the one recorded by me originally. The similarity of the code flows recorded from the pen test and from the automated test gives the developer a high level of confidence that if her fix passes the test, the security tester won't be able to reproduce it either. When the code is fixed, the developer records a new Appmap from the same test. She then attaches both code maps, before and after the fix, to a pull request, and also shares them with security engineers for review if needed. When we inspect the code map of the fix, we can see that user details are no longer retrieved from the database, and instead, the service returns a redirect to the login page as expected. We can quickly test the same in the running application. And that concludes our demo. In this presentation, we've demonstrated how visual code maps can complement existing tools and documentation in the process of discovery, communication, fixing, and reviews of code flaws. So what are the Appmaps changing in the work of security engineers and developers? Well, as a security engineer, I can complement my report with code maps of my attacks that help other teams understand how and why my attack worked. As a developer, a glance at a code map attached to a pen test report quickly reveals what part of my code is vulnerable, how to build automated tests to replicate the issue, and then use the maps to validate that the issue is indeed fixed properly without side effects. Additionally, after delivering the fix, I can use code maps to document my solution. This will speed up the code review, but also work as an example of how to write clean and secure code for others. Thanks for watching. If you have any questions, check us out at appland.com. Bye.